In this video, we're going to continue examples from chapter 5.3, and I just want to remind you of the sum and the difference of sum and difference identities for cosine. Cosine of A plus B equals cosine of A cosine of B minus sine of A sine of B. Cosine of A minus B equals cosine of A cosine of B plus sine of A sine of B. And just as a reminder, in these formulas, our signs are different from here to here. All right, so for your homework tonight, you're going to have to work problems in a couple of different sections in this chapter or in this section. So let's go ahead and get started. It says use identities to fill in the blank. So, I look at this and my first thought is, what the heck is this? And then I see that I only have one trigonometric function that I can put in here. So my second thought is, do these angles add to 90 degrees? Because if they add to 90 degrees, then we're just using our simple cofunction identity. So let's see if they add to 90 degrees. 2 pi over 3 plus negative pi over 6. Let's find a common denominator. 4 pi over 6 plus negative pi over 6 gives us 3 pi over 6, which is pi over 2. I know pi over 2 is 90 degrees. So this is probably just a simple cofunction angle because these two angles are complementary. So the cofunction for sine is cosine. So cosine should go here. The next one looks very similar because I only have one trigonometric function here. And I notice that if I add these two angles, 72 degrees plus 18 degrees, that's 90 degrees. They are complementary angles. So I can put tangent here. This last one is a little bit tricky though, because I notice that 24 degrees plus 66 degrees is 90 degrees, and my first instinct is to say, oh, it's got to be cotangent of 66 degrees. But that's not necessarily true, because in this example, I know that tangent of 24 degrees equals cotangent of 66 degrees, not the reciprocal of cotangent of 66 degrees. So what's the reciprocal of cotangent? Well, that's tangent. So this is a little bit tricky, right? Because I had to use my cofunction identities to get this, and then I had to use my reciprocal identities to get this. So this is going to be tangent of 66 degrees. So be careful on your homework. Make sure that you're using your identities correctly. This is my cofunction identity followed by my reciprocal identity to make sure that it's fitting this correct form. All right, so what's the next set of instructions say? It says find one angle theta that satisfies each equation. I feel like we're going back to chapter 2 because we had problems just like this in chapter 2 with cofunctions. I want you to notice that sine and cosine are on two different sides of our equation. We know that sine and cosine are cofunctions, and we know that these angles here must be complementary for this to be equivalent. So all I have to do is find values, right? Complementary angles, add to 90 degrees, set up this equation, find these values. So how many theta do we have? We have 6. Theta equals 90 degrees. What's 90 divided by 6? Well, it's 15 degrees. So that's one solution of theta that'll work here. So the sine of 15 degrees, if I put 15 degrees in here, I know that should equal the cosine of 75, does it? Well, 2 times 15 is 30. 3 times 15 is 45. So it looks like this will work, 75 degrees. Good. All right, so this again, I have cofunctions. So I'm just going to take these two, I'm going to sum them to 90 degrees. And I'm using degrees because I have a nice little degree symbol right here, right? Otherwise, I would use pi over 2. So when I subtract, I get 87 degrees. When I add these two, I get 5 theta over 4. Okay, I'm going to move this up here. I'm going to multiply both sides by 4. 5 theta equals 320, and 28 is 348 degrees. And then theta is just going to be some really ugly number. Right, and we can convert that to decimal if we wanted. It's going to be 60-some degrees. Okay, so 69.6 degrees. So it's really up to you if you want to do that conversion. All right, so let's go ahead and read our next section of problems. It says write each expression as a function of theta. When it says as a function of theta, what does that mean? That means you can't have any other numbers inside. So it needs, all of your trigonometric values need to look like this. They cannot have negative theta. They cannot have theta plus pi over 2, right? These are no-nos. They must look like this. We have to have functions only of theta. So how do we do that? So I'm going to start off by saying this is a different formula, the a minus b formula. So I'm going to write that using the formula. It's going to be the cosine of theta, cosine of 270 degrees, plus the sine of theta, sine of 270 degrees. And now I know the values of these. Cosine of 270 degrees is 0. So when I multiply this value by 0, it's going to be eliminated. Sine of theta, what's the sine of 270 degrees? It's -1. So my final answer is negative sine of theta, and I satisfied the constraints of a function of theta. Sine is a function of theta. All right, so we're going to do the same thing for this one. We're going to use the cosine of a plus b identity. I'm going to say the cosine of 90 degrees, cosine of theta, minus the sine of 90 degrees, sine of theta. And the cosine of 90 degrees is 0. So this part of my expression is going to reduce out. But the sine of 90 degrees is 1. So this reduces out, and it looks like we get the same answer that we got above. It's negative sine of theta, and again, my function is in terms of theta. Sine is my function, theta is its input. All right, so I'm not sure we're going to have enough time to do all of these. I might have to start up another video, but let's get started on this. It says find the cosine of s plus t and the sine of s plus t. And these are, this is the information that we're given. We're given that the cosine of s is -8 over 17, and the cosine of t is -3 over 5. And s and t, the angles s and t, are both in quadrant 3. So if I take a look at the cosine of s plus t, that's going to be the cosine of s, cosine of t, minus the sine of s, sine of t. Okay, so if that's a true statement, I need the cosine of s, the cosine of t, sine of s, and the sine of t just to do the calculation. And they've only really given me the cosine of s and the cosine of t. So how do I find the sine of s and the sine of t? Well, I'm just going to use my Pythagorean identity, and remember that my angles are in Q3. So when I find the sine of s, since it's in Q3, it should have a negative value. When I find the sine of t, it should also have a negative value. So I'm just going to use my Pythagorean identity. sine squared s plus cosine squared s equals 1. Sine squared s plus negative 8 over 17 squared equals 1. Sine squared s plus 64 over 289 equals 1. Sine squared s plus, when I subtract that, I'm going to get 2, I need to subtract that from both sides. I'm going to get 225 over 289. So when I take the square root, I get negative 15 over 17. You know, that's also, if you think about it, that is also a nice right triangle that you can set up. It's an 8, 15, 17 triangle, one of your special Pythagorean triangles. So now how about cosine of t, sine of t? Well, sine squared t plus cosine squared t equals 1. Sine squared t plus negative 3/5 squared equals 1. Sine squared t plus 9/25 equals 1. And then sine squared t equals 16 over 25. So when I take the square root of that, and remember that it's in quadrant 3, I get negative 4/5. And that's a 3, 4, 5 triangle. So I'm going to erase this work. You should leave it on your homework. But now I'm going to go ahead and plug these values in to find cosine of s plus cosine of t. All right. So cosine of s plus cosine of t, we have, let's see, cosine of s is negative 8 over 17. Cosine of t is negative 3 over 5 minus the sine of s is negative 15 over 17. And the sine of t is negative 4 over 5. So I get a nice 24 over 85 minus, what's 4 times 15? 60 over 85. So I have a nice, let's see, 36 over 85. And I don't think that reduces. So I'm going to leave it just like that. Okay, so next we need to find the cosine of s minus t. So how do we find that? Cosine of s minus t is the cosine of s, cosine of t, plus the sine of s, sine of t. Well, it's just going to be these two values, but added this time, because we have cosine of s, this is the same as this is the same as this. We're just adding instead of subtracting them. So I'm going to go ahead and use these values and add them instead. 24 over 85 plus 60 over 85 gives me a nice 84 over 85. And that's my final answer for cosine of s minus t. Okay, so I'm going to start up a new video and do 2 more examples from this section.